Assalamualaikum warahmatullahi wabarakatuh. So my name is Muhammad Firdaus Iman and I will explain to you about my FRP project, which is the load balancing method. So we will proceed to the first part, which is the introduction. So the overview for our load balancing method, we need to know first what is the pre-stressed concrete structure. So pre-stressed concrete structure, or known as the PSC, used in the early 1900 and developed as one of the important structure a few decades later in making the heavy loading structure, heavy sustained loading structures such as the bridges and girder. And then the second thing is even the RC structure, although they are strong in comparison, they lack the tensile forces. So with the presence of the PSE, they help to improve the tensile forces with the pre-stressing steel installed in the concrete section. And then if they still use the RC structure in making the superstructure, the lack of tensile strength or tensile forces will eventually lead to the cracking effect or chambering effect when the dead load is applied. And then the problem statement for this project is, the first thing is the load balancing method does not allow any deflection at service limit state. And then for the structural members such as the bridges and girder, always cause crack and chamber. So the load balancing method is required to be used in the analysis to avoid any deflection happen during the service condition. And then lastly, this method is common among the post-tension member than the pre-tension member, where the post-tension member contribute the majority of the construction industry, such as the post-tension slab, and then leaving the pre-tension member. So the load balancing method enable the pre-tension member to experience its full potential in terms of efficiency itself. And then the objective for our project is to demonstrate the use of load balancing method in the application of structures. And then we're able to help the designer for analyzing, designing, or calculate the complex structure. And then lastly, we're able to compare the easiness or to compare the ease of using the load balancing method compared to other method. Basically, the other method, they have three main method used in the PSC design, which is the strength, stresses, and load balancing method. So we will compare between each other and to see which one is the most efficiently used. So we'll proceed to the literature review. So in the literature review, there will be a table of comparison where the findings will specify about the deflection itself. There will be three authors. We'll start with the Lance Arluck, where he said that the both method, which he referred to the stress and strength concept, prioritize the safety approach, which the concept, the stress and strength concept mentioned about the limit of allowable tensile effect from the load applied on the structure, but leaving the precession force from utilizing to reach its potential. And implication happen such as unnecessary cracking at the origin limits among the act of chamber. The second point, he said that he referred to the if we use the stresses and strength concept, the chamber and cracking will happen unless we use the load balancing method, where we were able to avoid the deflection. And then secondly is the T. Wiley. He said about the advantages of the load balancing method. He said that there will be no deflection anywhere along the beam, as is already known. The load balancing method treats the beam as the net deflection. And this guy he used the theoretical studies book, which introduced concept of load balancing method. And then the last author, he argued, the last author held the Sousas, Trejos, Mitolis, Konstantinos, Pisaras, and Ionis Tegos. So the finding, in this finding, they argue that the load balancing method still not able to control the deflection, because deflection, the factor of deflection also depend on the pre-stress losses. So the method of controlling the deflection is by using the reinforcement, and using the low shrinkage concrete. And then we will proceed about the third part. The third part for this project, which is the methodology. We start from the last two, which is data collection and sources. In this part, I will explain to you how we are able to design the flowchart and use application of load balancing method in structures. So for the structure is I use the PT slab as the structure, and based on the design flowchart, we will able to design the PT slab from the start until the end of the process. So the data collection sources I get is three. There's three guideline, which is the Euro code number 2, the TR number 43, which is the technical report number 43, and then the British Standard Euro code. So we start with the design flowchart. Means the first thing is we design the structure layout. Means the slab in terms of span, how long the span, how long the width of what is the width of the span, and then we determine the thickness and the depth of the span, and then after that in the structure layout we must also specify the loadings and the properties of the concrete to be able to calculate the total loadings that imposed on the structure. After that, we will determine the tender profile and the balance load, followed by the analysis of pre-stress force and losses and the secondary effect. Then we will do the analysis of action, where after we get all the sign of loadings such as force, we will we will calculate the bending moment and draw the bending moment diagram and shear diagram. And then we will analyze the primary and secondary effect of pre-stress, which is the moment itself. And then after that, we will check the serviceability, flexural adequacy, or simply to be said, the service limit state, where we'll analyze whether the forces after losses, the pre-stress losses, we will check the pre-stress under transfer condition and under losses. And then we after the service limit state, we will proceed to the ULS, which is the ultimate limit state, where we'll check the slab and compare with the flexural strength and shear strength to make sure it does not allow to exceed the limit. And lastly, and then we will check the serviceability for the deflection and vibration for the PT slab, and we will consider refinement to design tender profile and tension enforcement, which means is we will check if the slab will need any additional slab, and then we will do structure detailing. So then for the last part is the conclusion. The conclusion, what is the future works? For the future work after this, I will learn about the software that will be needed for modeling the structures. And then after that, I will modeling the structure in the software and obtain the parameters as a deflection, force, secondary moment as the final result. And I will do the comparison of the answer to other three methods, which is the stress, strength, and load balance method. And then lastly, I will check whether my objective that is determined is achievable or not. For the objective achieved, so for the end of the project, two objectives is achieved, where I able to compare the ease of using the load balancing method and to demonstrate the load balancing method in the application of using the PT slab. Lastly, about the Gantt chart for future works. So this is my Gantt chart. Firstly, I will collect the Gantt chart for final project. It takes about 66 days, starting with the quality information, and then learning software for modeling purposes, obtain the result from the software, and then I will analyze and design using load balancing method, and also the comparison, the result comparison to the result and the two methods, which is the stress and strength. And then I will do the discussion which is discuss and compare the method, and then I will do the conclusion and recommendation for the other people who will do the same research as me, and then I will submit to the supervisor, and that's it. Thank you. Assalamualaikum warahmatullahi wabarakatuh.